Hey guys, in this video I'm going to be explaining the tetravalency of carbon. From that word tetravalency of carbon, what do you think it means? In the ground state, ideally, carbon is called divalent. Yep, that's the word. Why? Not because it has two electrons in its outermost shell, no. It's divalent because it has two unpaired orbitals. So at this point, valency is not going to be number of electrons in the outermost shell. For carbon, in this case, valency is defined as number of unpaired orbitals. Ideally, carbon has valency of 4. That means it has 4 electrons in its outermost shell. But out of the 4, only 2 are unpaired. So as you can see, this is the first guy, which is 1s2, and that's what you're having here. First shell. Then in the second shell, it's divided into 3 parts: 2s, and then for the 2p, you have 2px, 2py, and 2pz. So if you notice here, 1s is completely filled with 2 electrons, which is this. Then the 2s2 is completely filled with 2 electrons, which is also this. But the 2px just has 1 electron, which is this. 2py just has 1 electron, which is this. 2pz, nothing. So if you look at this, it's only 2 parts, 2 electrons here that are incomplete, that are unpaired. So that's why you say that it is divalent. Remember, just 2 unpaired orbitals. But in its excited state, this case here is called the ground state. In carbon's excited state, the carbon there changes from divalent to tetravalent, meaning that it now becomes 4 electrons or 4 unpaired orbitals. Let's use that. Why? That's because 1 electron that is here leaves this guy and comes to fill up this missing space here to now form 4 unpaired electrons, and that's what you have as this. As you can see, the 4 are now unpaired. So in this case, you still have your 1s2, which is this, completely filled, but the 2s is no longer complete, it's no longer paired, it now becomes unpaired. So 1 electron from here left to come and fill up this guy in 2pz, and that's what you have here. So if you check it here, 2s is incomplete, that's why it's 2s1. Now for 2px is incomplete, supposed to be 2, but it's just 1 that is there. That's what you have here. 2py is supposed to be 2, but it's just 1 that is there. That's what you have here. Then 2pz is also now half, and that's what you have here. Instead of it to be 2, 2, 2, 2, is now 1, 1, 1, and then this is what you call tetravalent. Now you're just having 4 unpaired orbitals. So electrons from different atoms or elements come to fill up these guys to now make it complete. So it's that simple. So this is tetravalent carbon. Carbon atoms in organic compounds are usually tetravalent and they are not divalent. For carbon to form an organic compound, it must be tetravalent. That thing that I just explained about one of them here leaving to come and fill up this guy must happen before carbon can form an organic compound. If it does not happen, carbon will remain divalent and to only form inorganic compound. Remember, in its ground state, this is how it is. Excited state, this is what it forms: tetravalent carbon. It should also be noted that a carbon atom in an organic compound must also always be surrounded with 4 bonds, a total of 4 bonds. As you can see, 4 bonds. Ability to form 4 bonds with other elements. 4, because the electrons that are there, only 4 are unpaired. The ability of changing from divalent to tetravalent is what you call hybridization, and that is what we're going to explain in the next video. See you in the next video. Have a lovely day. Bye.